right, so let's look at completing the square. Remember the steps that I gave you on the board and refer to them often as much as you need to. So let's get started looking at number 3. All right, so this is already in standard form, so let's go ahead and put parentheses around the first 2 terms. Leave a little room right here to put your constant, and put positive 56 on the outside and leave a little bit more room and let it equal 0. Now, important thing to remember is when you're completing the square, you do not want anything other than 1 in front of your squared term. So what we're going to do, if that happens, is we'll factor it out. But we have a 1 here, so we're in good shape. So let's go ahead and complete the square by taking our middle term, which is 18, and we'll divide it by 2 to get 9. After you half it, you'll raise it to the second power. So we're going to put plus 81 inside our parenthesis. This being an equation and we want to keep it in balance, after we add 81 on the inside, we'll subtract 81 on the outside. 81 minus 81 is 0, so that keeps the equation in perfect balance. So after we've done this, what we created right here is a perfect square trinomial. A perfect square trinomial is a binomial squared when you factor it. So to get the binomial, you take the square root of x squared, which of course is x. If you have a minus in the middle of the trinomial, you'll have a minus in the middle of the binomial. And then the square root of 81 is 9. So you'll have x minus 9 squared. Now out here with your 2 constants, you have 56 minus 81, which is a negative 25. Okay, so this right here, if I replaced 0 with y, this would be our vertex form. So I can see that I would have a vertex point of 9 and negative 25 for my parabola, with an axis of symmetry at x equals 9. Now let's find the roots or the x-intercepts by solving this equation. To do that, I'm going to add 25 to both sides. That'll give me x minus 9 squared is equal to 25. Now solve by taking the square root on both sides. When you take the square root of x minus 9 squared, that's simply going to get rid of the square, leaving you with x minus 9. Over here, the square root of 25 is positive and negative 5. Now solve by adding 9 to both sides. When I solve, I've got to do 5 plus 9, which is 14, and negative 5 plus 9, which is 4. So my solutions are x equals 4 and x equals 14. Looking at number 4, the first thing I'm going to do is add 30 to put this in standard form. So I'm going to put a parenthesis around 2x squared minus 16x, and I'll put my positive 30 on the outside. Once again, leaving room here for my constant and here to do the opposite. As I told you before, you don't want a number in front of your squared term. Since we have a 2 here, I'm going to factor it out of my parenthesis only. And that'll give me 2 times x squared minus 8x plus 30. Now take 8 and divide it by 2 to get 4. And 4 squared is 16. So I'm going to add 16 inside my parenthesis. Therefore, I'm creating a perfect square trinomial. Now, I didn't really add 16 though, because there's a GCF of 2 out here. I actually have 2 times 16, which is 32. So when I go outside, I'll subtract 32 instead of 16. So now I have 2 times, being my perfect square trinomial, the square root of x squared is x. If you have minus in the middle of the trinomial, you'll have minus in the middle of the factored binomial. The square root of 16 is 4. 30 minus 32 is negative 2. So this tells me that my vertex point is at 4 and negative 2, with an axis of symmetry at x equals 4. Now let's find our x-intercepts, which will be the solutions or the roots of this equation. To do that, we want to get x minus 4 squared by itself. So first, we'll add 2 to both sides. Next, we'll divide both sides by 2. And now that I've got the square by itself, I'll get rid of the square by taking the square root on both sides. When I take the square root of x minus 4 squared, that will give me x minus 4. The square root of 1 is positive and negative 1. Now let's add 4 to both sides. And so I'll have 1 plus 4 and negative 1 plus 4. So x is equal to negative 1 plus 4 is 3, and 1 plus 4 is 5. So if I have my vertex point at 4 and negative 2, and I have my roots or intercepts at 3 and 5, I've got my parabola. Okay, on the back, number 5, let's add 3 to put this in standard form. Okay, so I've parenthesed up my x squared and my x, and my constant term is on the outside. Noticing that I have a 4 in front of my x squared term, I'm going to take a GCF of 4 out. So I'll have 4 times x squared minus 2x. Okay, now let's find our constant term. So we'll do 2 divided by 2 is 1, and 1 squared is 1. So I'll add 1 on the inside. But I didn't really add 1, did I? 4 times 1 is 4, so I actually added 4. So I'm going to go outside and subtract 4. So now I have my perfect square trinomial. So 4 times the square root of x squared is x. I've got minus in the middle of the trinomial. I'll have minus in the middle of the factored binomial. And the square root of 1 is 1. 3 minus 4 is negative 1. Okay, so let's get x minus 1 squared by itself by adding 1 to both sides and dividing both sides by 4. Now let's take the square root of both sides. That's going to give me x minus 1 is equal to positive and negative square root of 1, square root of 4. Solve for x by adding 1 to both sides. So I'll have 1/2 plus 1, which is 1 1/2, or 3/2. Then I'll have negative 1/2 plus 1, which is 1/2. So 1/2 and 3/2 are my two solutions. Now number 6 is probably your toughest one on the page because you have to deal with a lot of fractions on this one. So if you parenthesis up your 3x squared plus 10, you'll see that you have an x squared term in front. You've got a 3. So we've got to get rid of that by factoring out a GCF of 3. 3x squared divided by 3 is x squared, which is exactly what you want to happen. But 10/3 doesn't divide out, so we have to leave that as 10/3. Okay, so now in order to find our new constant term, I have to take 10/3 and divide it by 2, which is a copy, change, flip situation. So on this problem, I'm going to cross cancel 2 and 10 to get 5/3. So I'm going to now take this and square it. 5 times 5 and 3 times 3. So I'm going to add 25 ninths. But remember, I didn't add just 25 ninths. I added 25 ninths times 3. 3 into 3, 3 into 9. So I actually added 25/3, which means I have to go out here and subtract 25/3. So this is a very unattractive equation, but we're still rocking on. So now we have 3 times the square root of x squared is x. If you have plus in the middle of the trinomial, you'll have plus in the middle of the binomial. The square root of 25 is 5. The square root of 9 is 3. So we have x plus 5/3 squared. Out here, well, my goodness, let's see what this is. 3 will go into 25 8 times with 1 left over. So we have 8 minus 8/3, which is negative 1/3. Okay, now to solve for x, this is vertex form, we need to get the square by itself in order to solve for the roots. So let's add 1/3 to both sides. And then we'll divide both sides by 3. So I'll get x plus 5/3 squared, and this is going to be a copy, change, flip situation, which is 1/9. Now to solve, let's take the square root on both sides. This will give me x plus 5/3 is equal to positive and negative. The square root of 1 is 1. The square root of 9 is 3. So now we'll subtract 5/3 from both sides. To get x is equal to, we'll have negative 1/3 minus 5/3, that same signs, so we'll add and take the sign. So negative 2 is a solution. Then we'll have 1/3 minus 5/3. 1 minus 5 is negative 4/3. So we get negative 2 and negative 4/3 as our two roots. Number 7, let's add 5 to both sides to put it in standard form. Okay, so let's go ahead and factor. This is not a perfect square trinomial because I have minus 16 here, and this last term has to be a positive in order for it to be a perfect square trinomial. So let's parenthesis up the first two terms. Now take 16 and divide it by 2 and square it. So I'm going to add 64, which means I'm going to subtract 64 out here. Okay, now this is my perfect square trinomial, so the square root of x squared is x. I have plus in the middle of the trinomial. I'll have plus in the middle of the factored binomial, and the square root of 64 is 8. Now here, this is same signs, so I'm going to add and take the sign. Okay, let's get the square by itself by adding 80 to both sides, and I'll have x plus 8 squared is equal to 80. Let's square root both sides. The square root of x plus 8 squared is x plus 8. Now over here, I know it'll be positive and negative, but we need to take the square root of 80 and simplify it. So you need two terms that you can multiply together to get 80. 8 times 10 is 80, which is 2 times 4 and 2 times 5. 4 will further break down into 2 times 2. So you've got two pairs of 2's. So bring out a 2 here and leave the 5 behind. So you end up with 4 square roots of 5. Now solve by subtracting 8 from both sides. Take the minus 8 and put it in the front as a negative 8, and put your positive and negative 4 square roots of 5 in the back. And these will be your two solutions or your two roots. Number 8, let me erase this so we'll have our room. Let's subtract 69 from both sides, and we'll have 3x squared minus 30x, and then minus 69. Okay, so let's factor out a 3 because we want 1x squared, not 3x squared, and that'll give me x squared minus 10x. Now 10 divided by 2 is 5, and 5 squared is 25. But we really didn't add 25, we added 3 times 25, which is 75. So let's go outside and put minus 75. So now we have our perfect square trinomial. The square root of x squared is x. If you have minus in the middle of the trinomial, you'll have minus in the middle of the factored binomial. The square root of 25 is 5. Now out here, I need to add these two together because they're same signs. And there we go. Now let's solve for x minus 5 squared so we can take the square root. So let's add 144 to both sides. And divide both sides by 3. Okay, so far so good. Let's take the square root, and we'll have x minus 5 is equal to the positive and negative. Well, let's go up here and simplify 48. So I know that's 16 times 3. Since 16 is a perfect square and 3 is a prime, you can go ahead and square root that. The square root of 16 is 4, giving me 4 square roots of 3. Add 5 to both sides, and once again, go ahead and put the positive 5 in the front. Then the positive and negative 4 square roots of 3 can follow behind, and that'll give you your 2 solutions. Now looking at number 9, we're in good shape here, so let's go ahead and parenthesis up the first 2. Take your middle number and divide it by 2, and then square it. So we're going to add 36 here, which means we'll subtract 36 here. So this is my perfect square trinomial. The square root of x squared is x. You have plus in the middle of the trinomial. You'll have plus in the middle of the factored binomial. The square root of 36 is 6, so we'll have x plus 6 squared. Now if you have 43 minus 36, that's going to give you a positive 7. Now subtract that 7 from both sides, so I bet you can see what's about to happen. We take the square root of both sides, and that'll give me x plus 6 is equal to positive and negative. The square root of 7 is not going to simplify, but that negative sign will. This is an imaginary unit, so that's got to come out as an I. Now subtract 6 from both sides. Go ahead, once again, put that minus 6 in the front, and put positive and negative I square roots of 7 in the back. Number 10. Let's subtract 16x from both sides. We have 4x squared minus 16x plus 76 equals 0. Factor out a GCF of 4. Okay, so now take 4 and divide it by 2 and then square it, and we get 4. But we didn't really add 4, we added 4 plus 4, or 4 times 4, which is 16. That means I have to go out here and subtract 16. Bring down your GCF. The square root of x squared is x. If you have minus in the middle of the trinomial, you'll have minus in the middle of the factored binomial, and the square root of 4 is 2. 76 minus 16 is a positive 60. Now subtract 60 from both sides to get 4 times x minus 2 squared equals negative 60. Divide both sides by 4, and you'll get x minus 2 squared is negative 15. So once again, here we go. So we'll have x minus 2 is equal to the positive and negative square root of negative 15. That negative has got to come out as an I. 15 will not simplify. So add 2 to both sides, and you'll get x is equal to, this positive 2 needs to go in the front, and I square roots of 15 will go in the back. And that is completing the square. Remember, when you solve these and you get this original equation right here, this is your vertex form of a parabola. You can pull out your vertex point for these. Then, once you have solved for your roots, those are your x-intercepts. If they are imaginary, that means the parabola will not cross the x-axis. Okay, y'all have a great day.